Time.
Alrighty.
All right, it's the third Wednesday of the month. It's 7 o'clock. You're here at the Austin Go Meet Up. If you're confused about where you are, then stay. You might learn something. My name is Trevor, and we have Cody in the back here who founded this meetup. Cody and I are the co-organizers, along with the sub-organizer, assistant organizer, man about town, Ian Rimler. We're pleased to welcome you here to the Xth iteration of this meetup. We have a code of conduct, which is on the meetup webpage, and it's also the Go code of conduct, so that's great. Do the code of conduct thing. If you ever see any violations of that or whatever, you get in touch with me or Cody or Ian. We're always in the Pound ATX channel on Gopher Slack, so that's kind of where everybody hangs out now, I guess, instead of Freenode. I think I make that correct every time, and it's just because I say like RIP Freenode. Tonight we have a wonderfully named guest named Trevor, also, who has come here. We liked Brandon's talk so much last time we decided to have people from the same team twice in 2 months come by and talk to us about how to do it right. So I'm excited to see how to refactor some code for better test coverage, and it appears that lots of other people are too, because this is a pretty decent turnout for the meetup. So with that rambling and goofy introduction, I will let Trevor take it away.
Also, sponsorship.
Yes, sponsorship. I'm sorry, God, right as I was saying that. Yes, talk to us about sponsorship. There's maybe one slot left.
All right. Thank you very much for coming, everybody. I am here to talk to you about how we have introduced some techniques for expanding our unit test coverage in a fairly mature code base that's written in Go. I admit that I have a selfish motivation in doing this talk because while I've been developing software for about 25 years, most of that time it's been strongly OO or type languages, C# and Java, and Go is a different animal. And I've been to this meetup several times, and there's a lot of really smart people here, and so I'm interested in your feedback after I kind of go through and present the pattern. So a little bit about me. I work for Dell Technologies. I work in the IoT division. I've been working on EdgeX Foundry for about 18 months. I'm the chair of the core working group. There's the GitHub URL, EdgeX Foundry, after github.com, and then we're also on Slack. Pretty much everywhere on these resources, and also on Twitter on TSCon23, so if you see that handle, that's me. So I'm going to give you a little bit of background and some context around the use case that I'm going to present. And in order to do that, I'm going to give you a little bit of an idea of the platform, just so you kind of understand when I go through and show you the scenario, you understand where it fits in the larger picture. So this is kind of the overall platform architecture. And we talk about, on the south side of the platform, all the different devices that you might have, machine floor, manufacturing, that kind of thing. And all those different devices are going to talk different protocols. This is a very heterogeneous, fragmented market, is the IoT space. And some of these devices have been out there for decades, and they talk all kinds of different protocols, and people aren't willing to buy new stuff in order to integrate and have sort of this smart ecosystem. So what we do is we provide an SDK that allows users to create device services targeted at specific protocols, OPC UA, BACnet, BLE, MQTT, so forth. So that's all on the southbound side. This is where the readings come from. They're then ingested into this core data service, and that's kind of a data repository. It's not real long-term storage. It's not meant for that. It's meant for pass-through and simple transformations, but that's where the event data lives. And we also have several other, this is sort of the core area of the platform, because in addition to storing the data, we have a way for you to be able to actuate back down to a device. Metadata describes what is your device ecosystem, right? What are the devices, what profiles and capabilities do they have, how do I target those devices, how do I talk to them, what are their addresses, that sort of thing. That's all in metadata. And then we have an abstraction that's currently fulfilled by Console for doing registries like service discovery and configuration, because this is all a microservice platform. So then kind of above that, sitting behind the core services, we have a very simple rules engine. We have capabilities for scheduling, notifications, logging services, and basically this additional services box means anybody could plug what they want into the ecosystem here at this level. Then going out to the north side, that's where all your export your cloud integration, public cloud, or if you have an analytics engine that you want to export events to, all of those connectors would be up here on the top. So as cross-cutting concerns through this, we have security, which we're still kind of trying to flesh out 100%. And then we also have things around system management so that you can control all these services, okay? So devices on the south side send data in. We can operate through a rules engine and take simple actions that can then actuate back down to the devices. And we can send that data out to the north side. That's the quick overview, all right? But that should give you some context about what it is that we're building. So how did we get to have this mature code base with a minimum of unit test coverage? So EdgeX Foundry was originally called Fuse, and it had been incubating within Dell for about 18 months, and then they decided to make it fully open source. And so we contributed to the open source community under the Linux Foundation in April of 2017. The services were originally written in Java using the Spring framework, but as anybody who's used that framework knows, the service boot up times are very slow. There's a lot of reflection, there's a lot of dependency injections, all this stuff that's got to happen. And the service footprints were really large. So the first trade show that we took EdgeX Foundry out to, the people who were running in these very constrained environments said to us, no, this is way too big. It's way too slow. We can't use this. And we were like, well, what are we going to do now? Because we spent all this time and effort, and our target market's not really that hot on it. So there was some research that was done, and Go was chosen as a language that would be able to provide that smaller footprint and better performance. So a code base that we had taken about 3 years to write had to be converted feature by feature by a team of interns in about 4 months. Okay? So we don't need no stinking unit tests. We're just trying to get this thing up so that at the next trade show, we can have something to show and say, see, we took your feedback to heart. So as you can see there at the bottom, as of last month when we started really doing this, our coverage for the platform was only 17%. And in the last month, we've gotten that up to just north of 24%. So it's trending in the right direction. So here's what I'm going to cover today. The use case is basically adding a new device. You have to be able to provision a device within the ecosystem. And I'm going to show you the initial state of the code, sort of when we started this exercise, what it looked like. And I'm going to talk a little bit about how we separated some concerns that were in that code. Because there's really two pieces. You add the device, and then there are people who need to know, or services that need to know about that. So you send out some notifications. And I want to emphasize that we're doing a refactoring and not a rewrite, because we're targeting the very middle tier of the services. When you look at a service stack, at least this is the way I think about it. You have an API, you have some business logic, and then you have some persistence, okay? This is the piece we're targeting. Yes, there is refactoring that we could do for all of this to better align and separate the concerns within the full stack, but this is an iterative effort that we're undertaking. So this is the piece we're targeting. So as part of that, there's sort of a poor man's dependency injection that we use to isolate some concerns and make it more testable. And then I'm going to show how we use the Go tool cover to make sure that we've got everything covered within the execution path that we possibly can. All right. So first thing I'm going to show you then is the code related to adding a new device. Can everybody see that, or do you want me to make it bigger?
Oh, no, you need like 5 plus lines, man. That's why I sit in the back, by the way. I got all these.
Let me try 20. And maybe if I minimize this, we're not going to care about this. Is that better?
Where's the other half of your syntax highlighting, dude?
What's that?
I said, where's the other half of your syntax highlighting?
Okay, so should I make it bigger?
Probably one more jump would be good.
Yeah. All right, I'll try 24.
There you go. I can see that.
Okay. Okay, wow, that looks really big on my screen. Okay, so like I said, this is basically the request handler for adding a new device. This is the way it was before. So I'm just going to kind of go through this real quickly. The request would come in, we would deserialize from JSON into this device model. The next thing we would do is there's some checking, some validation that's buried inside of the router related to this particular property that has to be set, because otherwise we don't know how to talk to the device. And then there's some checks where we say, okay, the device is coming in and it's telling me what service it wants to be affiliated with. Does that device exist? Go look by name. Well, if I can't find anything by name, go look by ID. Subsequent to that, it's also doing the same thing with a profile. And the profile describes the capabilities of the device. Okay, so go look and see if the profile this device is telling me about exists by name, by ID. And then it does some other things related to, okay, we're going to validate the values of the operating state, and then we get around to adding the device, okay, through this DB client. That's an interface, by the way. All right, so at that point, persistence. Now, the next thing that happens is we have to send out the notifications. And remember, this is all happening while the caller's sitting out there waiting for you to do all this stuff. All right, so I'm going to go in here and I'm going to notify some device associates. And the first thing I'm going to do is I'm going to post out a notification. That notification will be sent out to anybody who's subscribing to the particular criteria of that notification. And then the next thing it's going to do is it's going to find the device service, and then it's going to try and call back through this function, and it's going to do this, and you can just see this is a mess. And the other thing too is that this HTTP client is tightly coupled in here. So what's happening here, if I can represent this accurately, is someone out here is telling us, hey, here's a new device. And this is coming in the API. And so then we're doing all these, first of all, we're doing validation. Then we're doing checks on service and profile. And then we're doing the persistence. And then we're doing the notifications. I mean, there's a lot of stuff going on in here, okay? And this, in fact, what happens here is, remember, the caller's still waiting. This is gonna make a callback to some device service. That device service is in turn gonna turn around and say, okay, give me the new device information. And that's gonna get responded. Then this is gonna do some handling, then it's gonna act, and then the confirmation is gonna come back. That's crazy.
Yeah.
So that has to be decoupled. All right? So that's the basic idea of what is going on within this one call. Oh, and then at the end we write OK. And here's your new ID. So that's simple enough. Okay, so let's get on with the pattern then. What I'm going to show you now is kind of the first, oh man, I hate doing this without a mouse. I'm going to show you the first iteration of the work on this. Oh, I need to. Okay. Okay. So, if you're observant, the first thing you'll notice is, remember how I said there was validation in the API router related to the protocols? You have to tell us what the protocols are in order for us to be able to directly address the device. You may notice that that's not here, and I'll go into that in a second because that's kind of a tangent. But we eliminated that, and so now we just do some basic deserialization of the device from the incoming request. And what we're doing is, there's 3 steps here. You may remember that within the notification, at the very bottom of that stack is a tight coupling to the HTTP client. So I actually can't unit test that thing without making a real HTTP call. I don't want to do that. So the very first thing that we set up was a mock for, or I should say a factory method, for being able to get either a real HTTP requester or a mock HTTP requester. Now, if you get a real one, obviously it's going to make a real HTTP request. But if you get a mock, then you can just simulate making that call. and getting a response. A more sophisticated way of doing this would allow me to, I could use something like mockery to stub out this interface, and I could, if I wanted to, I could test a failure coming back from the notification and things like that. But I'll get to why I'm not doing that in a second. So here we're just basically saying we're using the factory to be able to say, give me a real one, give me a fake one. So that's the first piece. And remember, in the previous call stack, that's all the way at the bottom. But here we're setting it up first, because we're going to use it when we set up this notification operator. So you can see here, okay, I've got my request. Here's my requester, right? And I'm telling it I want an HTTP requester. So I'm going to pass that into this notifier right here so that it can use it when it's ready to send out that HTTP call. But what's this other stuff? I got this channel going on here. What's happening there? So this channel is going to be used to tell the notifier about the device that was just added. Because as you can see now, the notifier is being called in a Go routine. So all this goes away, right? The caller is no longer going to wait for me to do this and have this complex interaction before I can send back a response. In effect, we cut it off here, because if I can save the device correctly, that's all the caller needs to know. And then the notifications happens asynchronously. Okay? So again, this channel that I'm creating here is going to serve to let the notifier know this device has been added. Okay? There's some other things in here related to configuration, related to the database client, related to logging and things like that. I'll drill into that in a second, but I want to go through this flow first. Now remember, this order was completely the other way in the last logic flow. Because now the very last piece of code in this router function is we're actually adding a device here. So let's drill into this. Okay, so again, all of these things we basically call operators. And so inside of this device package, inside of operators, I've got add, notify, request, DB, everything's self-contained in here for what I'm trying to do. And so once I feed all of the necessary elements into the add device, including the channel it's going to publish on, an interface for persistence, and then this is the contract that we received as part of the request that defines the device that we're trying to add. The router has called execute, and so now this is where we do all this same stuff. Go and look up the device service by name and by ID. Go look up the profile by name and by ID. And we error out accordingly if we can't find what we're looking for, because those are required. But let's say we do find all that stuff. Then once again, right here, we add the device. Now, if a device has to be uniquely named, so if the name is not unique, everything else checks out just fine. I tried to save it. No, it's a duplicate name. So then I will use this channel that was passed in to send an event out, but it has an error on it. And I'll show you the handling of that in a minute. If on the other hand, this is successful, then you can see right here what is on the event. It's the device's ID, its name, the method that was used in order to create the device, because this could be put if we're updating a device, or it could be delete. The service that is going to own the device, and then we publish it on the channel. Okay? That's basically just the piece for adding the device. So then let me go into the notifier. Now again, we're going back up. So here's the notifier. And you can see it requires a whole mess of stuff up here. When we get to execute, here's where we handle the channel. So remember that I started the notifier on a Go routine. I called this execute on a Go routine before I even did anything with the device adder. And the reason I did this was because if I didn't, this would block. It wouldn't get any farther, right? Because I'm passing that channel in and it's going to sit there and it's going to wait. So I have to call this on a Go routine. So when a message comes through, remember I said that if there was a duplicate name or any kind of error, let's say I can't connect to the database, whatever, any error that's on that message that I receive from that channel, I log it and then I just return. if everything worked, then I basically take all this information that I was fed, and this is where I go through and I post the notification. And then, as you can see here, okay, the device service needs to know about it. Here's where the callback is invoked. Okay, so if there was an error, the reason that I'm not using a sophisticated mock around doing this is, for making the HTTP call, is because the errors are just going to get logged in the test. Nothing has to be returned to the caller. There's no specific information because this is all happening on a different Go routine. So it's not going to affect the response that I'm going to return to the user. That's why there isn't really a sophisticated mocking around error conditions for the HTTP requester. But yeah, so basically this all happens in a separate Go routine, and it's all the same logic, and that's that. Now, one of the things that we did have to address, if you'll remember in the old logic, we had this big DB client. Let me see if this is the right. Okay. So remember, in the old logic, this DB client is an interface that's globally available within the service. Okay? And all I need for my operations is really a handful of methods, like 5 methods. Checking for the profile, checking for the service, adding a device, okay? But if we look at this guy, there's all this stuff. Okay, so I don't want to have to mock all this for my unit tests. So the way that I solved that was, inside of operators, we basically have this, db.go, and I created specialized interfaces using actually interface composition. As you can see here, this is where I'm going to load the device service, device profile. The whole operation requires device adder because I'm going to add and I'm going to check the profile, I'm going to check the service. So this is really the big interface, but I can take these definitions and compose this guy from those. And when I go into add, if we look at the constructor, you can see right there. That's the interface I'm expecting. So in the router, I have this type that conforms to this massive DB client interface. But this device adder interface only has 5 of those methods on it, right? And that type, that same type, will still conform to that interface because of the way Go deals with interfaces. It's actually very handy. I like it very much. So that's how that logic has been broken up. I know this is a lot, so let me just continue. I'm almost at a point where we can start having a discussion. Because once this is broken up, and I can step through this too if you'd like later. Once this is broken up, now I want to write some tests. And you can see inside of this folder, I've got add.go, notify.go, request.go, and then under each one of those, I have a test. And what's interesting about this was a little bit tricky, is when I'm adding a new device, I had to simulate that Go routine operation. Even though there's no, I don't want to test notification as part of add new device. I want to test notifications on its own. So that's where I'm basically setting up this wait group, and I'm using this anonymous function on a Go routine to simulate what the notifier would do. And I have to pass in here both an error and a success in order to know that, I'm getting the right result. But then basically down here, I just call, just like I do in the router, I new up the device, I give it a channel, I give it a database mock, and then I give it a test device. This is just like, a model that's been populated. Then you call execute. That will publish on the channel, which will run back through the test and make sure that you haven't, like your database mock can return errors, and in fact they do. Oh, I haven't gotten there yet. That's in my next step. These are all just success cases. So this is the mock for name, and you can just see they're all returning nil for their errors. But we use mockery in order to mock out interfaces, and then this is how you basically say, okay, for this method, I'm going to pass in these sample parameters. These are the values that I expect. And there's all these different types down here that I went through and created as stubs to be used within these tests. All right, so then this is just the notification mock. So this is an example of, as I'm running through these tests, you're all probably familiar with these table-driven tests, right? I basically say, okay, this is the name of the test. I want to give it, I try to provide it the database mock that will return the appropriate value in order to either pass or fail the test. These are very thin. They don't have a lot of inputs that result in an output so that I can say, given these inputs, this is the value I'm expecting at the end. Rather, I have to use the database mock and create the mock in such a way that it will either create an error or it won't create an error. And that's largely what I'm paying attention to here. Because you can see here, you know, I'm expecting errors as the last parameter. So then I go through this loop, and like I was saying before with the requester, I'm just saying I want a mock. I'm not actually going to make these HTTP calls. And let me see. Actually, let me just run this. Okay, let's see what this does. So we're going through the tests. Oh, I'm hitting the wrong key, shoot. And that's the wrong thing. I'm kind of getting off script here. Let me just continue on this then. Let me just continue on my plan, and we can come back to this kind of stuff in a discussion, because I don't want to lose the point that I'm trying to make. So suffice it to say that all this logic has been refactored into this operator pattern. We've separated the concerns. We have a channel that allows us to asynchronously handle things that the original caller doesn't care about. So as part of our make test, we use a make file to manage all of this. So I'm going to do a make test. You can see right there that it's outputting this coverage.out file. And the way this is defined in the make file is just like this. Right? This line right here will basically write out a file that shows you what your coverage profile looks like. And if you want to view that, what you do is you do this. And this will open a browser, and you can go right to, that's probably, this bigger. You can go right to the file, and you can see right here for device add, I've got a coverage of 45.7%. So what am I missing in this iteration? Oh, okay, so I'm missing some error conditions. This will show you, these lines are covered, these lines are not. And okay, so I'm missing another error condition there, and right there. All right, so I still have a little bit more work to do. This has all been great, refactoring this, but I can see that I still have a little bit more work to do. And probably the work that's going to be involved is fleshing out my tests a little bit more, rather than actually changing the logic that I've already written. So let me move to the next sort of iteration. Oops. This one right here. Actually, you know what? I can just do this. Okay, and then I'm going to run the make test again. And remember, we were at like 47.7% or something like that for the add.go. So let's look at the coverage one more time. I'm going to close this so I don't get confused. Okay, now we're at 100. Fantastic. And all those errors that you see are covered. Now, again, what I was trying to say before is you can see that what we've covered now are errors that are being returned by the persistence layer. That's what I was trying to get to. In the original test that I was showing you, there were no errors. Everything was returning a successful case. And so what I had to do was rewrite the test to include more mocks, right? Okay, so now I'm expecting some errors here. So that's what I was trying to say is the technique for this particular case, since there isn't any complex computation, it's more about loading resources that should exist. I use the mocks to control whether or not an exception is going to occur and be handled by the logic that is in the operator. Okay. So I think that's basically it. I've shown you what the logic looked like to start with. I've given you an overview of the problem that we were trying to solve, the functionality we were trying to accomplish. I showed how we separated the concerns. We used Go routines and channels to be able to do that and coordinate the operation. We were able to test the two pieces, the notification and the adding of the device independently, and we mocked out the dependencies that the logic needed in order to be testable, rather than having everything just buried and tightly coupled in these global variables. Okay? And I also showed how to deal with decoupling from this massive interface so that all the baggage that comes with these legacy interfaces doesn't affect your testing, so that you can streamline and really target only the logic that you want to test. So I think that's it. Any questions, please?
Can you talk a little bit about the mocking library and approach that you use and why you chose that?
Mockery just seems fairly easy. So the way that works is,
Well, maybe I should say what I usually do myself is I'll write a quote-unquote mock implementation of the interface that is basically just a struct. And every member of the struct is kind of like this, like a thing where if I have a method called foo, I have an on foo in the struct, and that function has the same signature as the method. Right?
Okay.
So then my implementation of that just delegates to whatever in my test I've set, on foo to be this function to return nil or whatever it's supposed to do in that case.
okay,
So I'm just trying to understand what the mocking library kind of helps you kind of abstract away, I guess.
well, the way that I was thinking about it is, okay, let's say I have several different, again, the database is where I'm controlling a lot of this logic flow in the test. That's where I'm simulating a lot of the conditions that my logic relies on. And what I didn't want to do was have to write 5 different types that implemented that interface for, the different use cases. So and the other thing too is that you can sometimes reuse the same mock instance in multiple tests. So it seemed to me to make sense that, okay, I've got this interface, rather than implementing the types, then all I have to do is use mockery to generate a stub, because that's what these are. These are basically stubs that are generated by mockery.
When you say implement the types of an interface,
So, I'll give you a simple example. I do something like that down here, where this is not a mockery type. Like, I implemented this.
okay.
I could use mockery, but it just didn't seem to make any sense for what I needed to do. So, you may be talking about a different technique, but one of the things that, we thought about was, well, shoot, are we gonna have to create all these mock types that, implement these interfaces, and that's just way too much work. So it seemed to us to be the best thing to do is to just use a tool that would auto-generate the stubs that we needed and then plug into the methods, right? Because this is a method, and this is a method, and this is a method, and then we just provide it the different test inputs that we want and tell it what we want to come out. And just, I don't know, it seemed to make sense.
Right, I'm saying my experience has been basically doing that, but not relying on the thing that uses any reflection. You just basically say, I implement the interface as a thing that it's just delegating to a similarly named struct member that has the same signature as that method, right? So if I set up and I need foo,
I see.
I need foo to return an error called not found or whatever in this particular situation,
I'll just say on foo equals, and I'll have a little func right there, or if it's more complicated, I'll have a factory produce these funcs or something to give me it for that scenario. Right, so you just basically like, just pop out, like you say, kind of just a very simple implementation of this interface that when I try to describe this pattern to people, I refer to it as like a pluggable mock, because I kind of like, I plug in the function that I need on that struct by just saying like, on foo equals this function that happens to behave this way, because that's what I need for this particular test.
Yeah, I see what you're saying. That just didn't occur to us.
Okay, well, it didn't occur to me necessarily, like it came, this was like a Peter Borgon or somebody like that, who I used to go kit for one and only one project. But I did like that aspect of his like testing philosophy. So I've always wanted something that does slightly a little bit more. I did a lot of Rails for a long time, and RSpec can be a foot gun, but if you use it right, it can also be kind of a game changer in terms of the speed of writing tests. I've always kind of hoped for something like that and and never really seen it. So that's kind of what I was wondering about.
So kind of piggybacking on that, we use this very similar strategy, and the one thing I do like about it is there's like functions that you can inject, like basically dependency inject into your mock. You can actually test the input values of those functions too.
Okay.
I don't know, does this framework allow you to do anything like that, or you just like say, with these inputs, give these outputs?
We primarily use it to say, because it's so simple, I mean, the logic that we have is really simple. We basically use it to say, given these inputs, we want these outputs, But believe me, we're only using a part of the capabilities, there's other things that you can do.
Do you use any assertion libraries or anything?
Not really. There have been a few developers that have, I couldn't find them right now, but there have been a few developers who have put asserts in their test to say, make sure that this piece of logic was called, and if it wasn't, then.
I meant more like just on the asserting, like turning things into one-liners, as opposed to like, so that, because if you've got to say like, if my value is this thing, then shut the test down, or throw an error or whatever. So like, one thing that I really liked is the testify library. I don't know if you've seen that, but you might really dig it, because it takes a lot of things that are like a 3-line logic check sometimes, like checking for an error being nil or whatever, just turns it into one. And one thing that's great is it has the same API as both require dot and assert dot. So require dot, if one of those fails, then it will just shut down subsequent like tests being run at all, right? So that's kind of nice because you can just sort of short circuit things. But it really made my tests a lot more readable because I could say just in one line like, what am I proving here?
Yeah.
You know what I mean?
Yeah, that makes sense. No, we don't really use anything like that right now.
You might grab it. It's very not at all like intrusive. You know what I mean? You're not like opting into a whole framework. It's just like you hand it the T, the testing handle basically, and then like whatever values you're testing. So it has a ton of things like assert true, assert not true, assert no error, assert nil, assert not nil, assert contains, like all sorts of stuff where you might find yourself writing some like dumb loop to make sure that like the slice that you returned actually contains the foo bar that you need. Like it'll just say assert contains and it'll just do it for you, So.
And you said that was testify?
Yeah, it's testify. It's made by some org or person called Stretcher, STRETCHR.
I've seen that name.
On GitHub. Yeah, it's
I know it's imported into our project.
It's like the one thing amongst all the different people doing Go at my company, which has like 1,800 engineers. It's like the one thing that everybody can agree on with tests. Like if you're kind of a purist about like just the standard lib, like you're still gonna want testify because it'll shorten your tests to make them that much simpler to understand like what's actually being asserted by the test.
Okay.
See, I think it's in the project. See if you can go back to that and just use it.
I don't know how to just use it. I mean,
Fair enough.
Do you have Go import? Because if you just say assert dot, it probably will find it for you. If you have Go import set up as a file watcher on Go.
I got no idea, honestly. I mean, there's a lot of stuff in the Go ecosystem, right? And you get it to a point where you're like familiar with, so I can't on the fly in front of a room full of people just go and like start doing that because I'll get
Oh no, I hear you. Yeah, as a public service announcement, if you're not using Go import, you might make your life simpler because it'll alter your import statements for you, so you can just start to use the package, and then Go import is a superset of the Go functs formatting on save stuff. So it actually just manages your. So if you like remove all references to like funct or log or whatever. Like, instead of like being like, hey, sorry, I can't compile your code because you forgot to go up and take it out of the imports, it just does it. You don't ever have to think about it anymore really, except sometimes it gets a little aggressive, but it's a CLI tool you install, and then in Go import, it'll recognize it if you go to file watchers, which for some reason you have to do for every damn project in GoLang. You can't just like set it globally, but file watchers will do the like on save kind of thing, so you can enforce like your format.
That's nice, because we have kind of a weird import scheme where, yeah, see, it gets out of sync all the time. Because we like to have these, you know, down at the
And Go import does too, and it will do that for you.
yeah, because we like to have these like down here, you know.
Right, yeah, exactly.
So yeah, that would be awesome to manage that a little bit easier. Any other comments? There was actually one thing that I was going to show you guys. So you remember that I was talking about the validation that happened in the original logic related to the incoming model, okay? I perceive that as a problem. So you have, let's say, a property on a model that you receive as a request. You want to check to see if it's populated. Maybe you want to check to see if it's a particular type, if it's within a particular value, and you put that in your API code, which sucks because there could be many endpoints that receive that same model. Now you have to put it in all those different endpoints that receive that model. So what we did was we made sure that when the model was decoded here, it would have the knowledge as to whether or not its state was valid. And the way that we did that was by putting a validator interface on all of our models that basically has this validate method. We hook that into unmarshal JSON, and then this is where all the rules, so you're talking about like the protocols is, we weren't even checking to see on the device if the ID or the name were blank. Right, those are required fields. We were waiting until it got all the way down to the database before we threw this error. Well, we can take care of that as part of the unmarshaling right up front, and now this logic is serialized. So that was a big win as well, being able to encapsulate that knowledge in the actual request models. Yeah.
So, do you remember ever creating websites from Notepad, just Notepad?
Oh, sure.
And what was the longest time you ever was put on hold?
Well, I've worked on, I don't know about Notepad, but I mean, I've had applications that have pended for seconds waiting for a response.
Oh, really?
Yeah.
What about the longest you've been on hold with someone on the phone?
Oh, I don't know. I don't know. What are we talking about? Utilities or credit card companies? What are we talking about?
Yeah, for the internet, for Yahoo. What's the longest you've been on hold for Yahoo?
Longer than I would like?
Yeah, I know. Do you have an exact number?
No.
No. I was on hold for Yahoo for almost like anywhere from like 7 to 8 hours.
I think I would have given up by then.
Yeah, I just had the phone down on speaker and I was just sitting there waiting for it. I don't think they ever picked up, but I know it was like longer than 8 hours though.
Isaac, did you have a question?
Yeah, that was more interesting. The team looks like. I assume we still have the same terms. Like, so how do you encourage these people to do testing? Like just like you're passionate about testing, but how do you encourage other people to be as passionate as you are?
Well, so our project has a semi-annual face-to-face meeting. So every 6 months, you know, there's 40 or 50 people from the different companies that are part of the open source project, and we get together and we talk about what we want to accomplish. And this last one that we had, we were all like, man, our unit testing is just not good. And onboarding developers and making sure that they have the confidence to alter the platform without breaking things. If we had better unit test coverage, that would really help, you know? So there's a technical steering committee, which is sort of the overarching governing body of the project, and they basically said, okay, this is where we're gonna raise the bar to by the next release. So it's kind of being driven from the top down. But it's funny because some of the developers who have been working on this, helping to increase the coverage, I had one of them write to me and he's like, you know, this is really Zen-like because I do the pattern and then I can right away, I can see the number go up. And I go into the coverage tool and the lines are red and then they become green. And it was just so funny to me. So it was nice to hear that kind of personal satisfaction coming from. Because a lot of people think when you're writing tests, especially if you have to go back and write and apply tests to a legacy application, people think of that as grunt work. And it's not really, because you have the ability to strategically refactor and understand how can we decouple some of this legacy logic. I mean, it takes a lot of thought to be able to decouple existing logic well to make it testable. You know, so I wish that perception wasn't there, but sometimes it's more glamorous to write the features that are, you know, going to be used by a user, and this stuff doesn't really get seen, but it helps the developer experience a lot. So I've been pleased.
Moving forward, are you all looking at adopting test-driven development, or are you looking just to write, continue to write the code and then write unit tests after that?
Yeah, so for I have a peer of mine within Dell, and he's sort of focused on leveraging EdgeX within Dell solutions, and he's a big proponent of TDD. So a lot of the code that he's working on from scratch, it's greenfield, right? So he's got the ability to go in and make code that's based on TDD. It's a little bit harder with this, but what I'm trying to do now, as features are being added, and I go and I review pull requests, I make damn sure there's no tests on this. This is the pattern we're using. Please refactor this pull request according to this example and that example and the other example. And I'm happy to answer questions on that. Right now, I think that's the best I can hope for.
Right.
Have you had any issues when you enable the race detector when testing these Go routines?
So that's an excellent question. Someone just pointed that out to me. It's funny you mentioned that, because we actually found a race condition issue in our code, and it's affected our most recent release. We're getting ready to do a dot release because of it. And someone brought that up, and I thought to myself, you know, no, I just didn't even think about it, but you're absolutely right. Yeah, that needs to be a part of it. In this area, it's not a problem, but we had some other areas where, yes, it was an issue.
Yeah, I just know sometimes for me when I'm writing a code that has a lot of Go routines in it, it's like hard to know, like,
Yeah.
is this race condition in my code or is it in my test
Yep.
of the code? So.
Yep. No, you're absolutely right. And I wish I would have thought of it, but I didn't. So, okay, can I ask a question? So, does it, for those of you who, you know, saw the presentation, again, this is an OO guy talking to the Go community. And my concern is that, you know, I'm not thinking about doing this in sort of an idiomatic way. Does this approach rub anybody sort of the wrong way? Like, why the hell would you do that? These are legacy patterns. Any kind of criticism about that, or concern?
Not so much criticism, maybe just for my own interest. As a percentage, how much asynchronicity would you say you got out of the second logic flow than the first one?
Okay, so I showed 3 different commits. I showed the original, then the first round of refactoring, which was the big change.
The first and the last.
The first and the last, none, because they were effectively the same business logic. It was just an increase in tests. I just added more tests, you know, in cases, more test coverage. So, but I will say that one of the things I'm thinking about, because I'm heavily influenced by domain-driven design, and I've worked in microservice architectures that rely heavily on eventual consistency. And so using those kinds of ideas, I do want to introduce more concurrency into the platform. Absolutely. And so to your point, that's something to be aware of. And, you know, using I think it's what is it?
It's just dash race.
Yeah, dash
You
race.
go,
On Go, is it on the Go build?
you can do it Go build, Go run, Go test.
Got it. Yeah, Go test.
Basically,
Right.
I mean.
Right, okay. All right. So yes.
I missed your kind of philosophy about how you're testing with it from the database back. Are you guys some people go as far as using an entire driver block, right? Like Datadog produced, I think, on a library. And to me, like, I don't understand why anybody would do that. So, especially in the container world, where I could just like drop a new containerized version of my database server choice and
Right.
just run tests against a live schema and like
Right.
feel good that I don't have some like weird obscure error in my driver model.
Right.
But some people feel completely the opposite. So I was just curious, if you guys are actually using a real database and test, or
No. Not in this case, it's all mocked out. The whole persistence layer is all mocked out. So the way it works is we have, like I said, we have this DB client interface.
Okay.
And that's where it stops. This is what the mocks use. Now underneath this, we support both Redis and Mongo. Right? And so if we were gonna test either one of these, it would be part of our integration tests. That's what we do right now, is we run like end-to-end integration tests with one of these providers sitting there.
Okay.
But for unit tests, I personally believe that unit tests should test, you know, the logic without any of the external dependencies. No
Yeah.
file system if possible, no network, no, you know.
I agree if you're not using SQL. I guess my opinion is that if you're using SQL, especially if you're relying on features like if you've heavily constrained a table to do some like polymorphic data model or something like that, like there's just it's just safer to go ahead. But if you're targeting those, I would completely agree with you. That's where I would do my test too, as an integration.
Yeah.
Yeah. Okay. So if you're not doing SQL, I guess the question.
Well, how do you keep your unit tests isolated then? Because they're gonna conflict, right? Or you have one container, I mean, I'm sure you don't have one container for unit tests, right?
No.
So if you're using a live database and one unit test writes data to it and another unit test also needs a database, then will you have conflicts or do you have something handling that or?
Just wipe it out. They just drop it on the table between your tests.
So that, but then they can't run parallel, right?
Oh yeah, if I wanted to run them, if I wanted to run that unit test setup, if I was dissatisfied with the time. Most of these are microservices, so I'm testing like half a dozen database models, and I've got we got a really small set of tests that we allow to go in to be tested against the live system.
Oh,
Right.
okay.
So like I'm basically like I want to know that like if I save this data and I've done a bunch of like referential integrity crap or whatever in my DDL, that like that all works.
So this is like the exception, not the rule, kind of like this just.
Yeah, that's the thing. Like I don't want some like, because I also worked forever on like really like old mature, shall we say, Rails projects that like do this sort of soup to nuts thing with everything, and so you're just like you find yourself like constantly seeing tests go through the entire stack just because.
No, that sounds exactly like how I would do it too. That makes perfect sense.
Yeah, it's kind of a subtle difference, but if you like, we always have one thing that's nice in tests. I think about the Go command line tool that I didn't learn for a couple until doing Go for a couple years is that the Go command line tool will ignore any directory that has that's appended with an underscore, right? So if you use the recursive, you know, dot slash dot whatever, like it will still ignore any directory with an underscore. So you need to affirmatively cd in that directory and run those tests, right? So we'll have like a separate step, like make file step to do that for those things. And we don't need to run those unless all the other like purely code-driven, mock-driven unit tests have passed.
No, I like that. It sounds totally like, if you tried to mock that out, it would be insane.
Right.
Any other questions, comments? Well, all right, I hope this was interesting. Thanks for letting me present, and I'll hang around for a little bit if anybody wants to chat. So, thanks very much.
It is more like probably like 4 or 6 hours.
If anybody parks in the parking garage downstairs, you can get, a parking violation receipt from the front.
It's great when it's it's not responsible.
Yeah.